June 12, 1944. 6 days after the largest amphibious invasion in history, and the American army had a problem nobody saw coming. They'd stormed the beaches of Normandy, broken through Hitler's Atlantic Wall, and pushed inland expecting to race across France toward Germany. Instead, they were stuck. Completely, utterly stuck. Not because of German tanks or artillery, but because of bushes. Except these weren't ordinary bushes. The bocage hedgerows of Normandy were ancient barriers that French farmers had built over 1,000 years. Thick earthen walls topped with dense vegetation, some 15 feet tall and just as wide at the base. The roots went down 10 feet or more, tangled with rocks and packed dirt that was hard as concrete. And they were everywhere. Every single field in Normandy was surrounded by these natural fortresses. For American tankers, the hedgerows became an absolutely death sentence. Every time a Sherman tank tried to climb over one of these barriers, it would tilt upward, exposing its thin belly armor, the most vulnerable part of the entire vehicle. And on the other side, German soldiers would be waiting with Panzerfaust anti-tank weapons. One shot to the exposed underbelly, and the Sherman would erupt in flames. The crew rarely survived. Tank commanders watched this nightmare unfold day after day. They'd send a Sherman forward, it would start climbing the hedgerow, and then the explosion would come. Black smoke, screaming men, another crew lost. The medics couldn't keep up. The replacement system was overwhelmed. And the tactical situation was getting desperate. Allied planners had expected to be 30 miles inland within a week in there, pushing toward Paris. But instead, they were advancing maybe for a few hundred yards per day. Every field was a separate battle for sure. Every hedgerow was a new problem. The Germans didn't need massive reinforcements. They just needed to wait behind these 1,000-year-old walls and pick off American armor as it tried to cross. General Omar Bradley, commanding the 1st U.S. Army, was watching his timetable collapse. He'd pushed his engineers to find a solution. They tried everything. Explosives to blow gaps in the hedgerows, too slow and too dangerous. Bulldozers to push through. They got stuck or were too vulnerable. Modified plows didn't work on routes that dense. Artillery barges to destroy the hedgerows, waste of ammunition and barely made a dent. Nothing worked consistently. The American advance was grinding to a halt in the Norman countryside, and nobody had an answer. Except maybe one sergeant who spent his nights scribbling in a notebook by candlelight. Sergeant Curtis G. Cullen Jr. sat on an overturned ammunition crate outside his tent on the night of June 11, 1944, watching another column of replacement tanks roll past. These weren't reinforcements for an advance. These were replacements for the Shermans that had been destroyed that day trying to cross hedgerows. He'd counted 17 tanks pass in the last hour. 17 crews who'd climbed into their vehicles that morning not knowing they'd be dead by sunset. The math was brutal and unsustainable. At this rate, the American armored force in Normandy would be ground down to nothing within weeks, and they'd barely moved 5 miles inland from the beaches. Cullen pulled out his notebook, a small field journal he'd been carrying since basic training. Over the past week, he'd been sketching diagrams and writing observations, page after page of notes about the hedgerow problem. Measurements he'd paced off from destroyed tanks to the hedgerows they'd been trying to cross. Angles of tank hulls when tilted upward. Observations about root density and soil composition. His crew mates thought he was obsessed. Maybe he was. But Cullen had spent his entire adult life solving mechanical problems, first as a cab driver maintaining his own vehicle in New York City, then as a soldier maintaining cavalry reconnaissance vehicles. Every problem had a solution. You just had to look at it from the right angle. The hedgerow problem, as Cullen saw it, wasn't really about the hedgerows themselves. It was about geometry and exposure. When a Sherman tank approached a hedgerow and tried to climb it, the front of the tank would rise upward as the tracks grabbed the sloped earth. The entire vehicle would tilt backward at maybe 25 or 30 degrees. This tilt exposed the tank's belly, a flat plate of armor only 1 inch thick, compared to the 3-inch frontal armor. German soldiers positioned on the far side of the hedgerow with Panzerfaust anti-tank weapons would simply wait. The moment that thin belly armor appeared above the hedgerow crest, they'd fire. The shaped charge warhead would punch through the thin plate like it was paper, and the resulting explosion inside the crew compartment was almost always fatal. Cullen had watched this happen. He'd been with recovery crews pulling burned-out hulks away from hedgerows. He'd seen the entry holes on the underside of destroyed tanks, perfect circular penetrations surrounded by blast scorching. He'd helped pull bodies from those tanks, or what was left of them. The images haunted his sleep. The smell of burned flesh and diesel fuel mixed together became something he couldn't escape even when he was miles from the front lines. Something had to change. The current approach was mass murder disguised as tactic. The Army's engineers had tried various solutions, none of them effective. Explosive charges placed at the base of hedgerows could blast gaps, but it required combat engineers to approach under fire, plant the charges, retreat, detonate, then wait for the dust to clear before tanks could advance through the gap. The process took 20 to 30 minutes per hedgerow, and there were thousands of hedgerows. Plus, the explosions advertised exactly where the Americans were planning to advance, giving Germans time to reposition defenses. Bulldozers had been tried, but the earth-moving blades couldn't handle 1,000-year-old root systems. The dozers would get tangled in roots, stall out, and become sitting targets. Artillery bombardment was equally ineffective. You could drop 100 shells on a hedgerow and barely scratch it. The ancient roots and compacted earth absorbed blast effects that would demolish buildings. Cullen kept coming back to the same conclusion. The problem wasn't that hedgerows were impossible to breach. The problem was that every current method required either exposing the tank's vulnerable underside or taking so much time that the advantage of armored mobility was lost. What they needed was a way to go through hedgerows quickly, while keeping the tank's thick frontal armor facing toward the enemy at all times. If you could punch through at ground level, maintaining a level or nose-down attitude, the Germans would be facing 3 inches of sloped frontal armor, something their Panzerfausts couldn't penetrate. The tactical problem became an engineering challenge. How do you cut through 10 feet of packed earth and root systems while maintaining forward momentum? The answer came to Cullen on June 12, during a supply run to Omaha Beach. He'd been sent to pick up spare parts for reconnaissance vehicles, and the route took him across the beach where the D-Day landings had occurred 6 days earlier. The beaches were still littered with debris from the invasion, destroyed landing craft, abandoned equipment, shell craters, and everywhere, scattered like a child's discarded toys, German defensive obstacles. The Germans had planted thousands of obstacles along the beaches to destroy landing craft and block armored vehicles. There were Belgian gates, steel frameworks designed to tear out the bottoms of boats. There were teller mines attached to posts. And there were Czech hedgehogs, anti-tank obstacles made of heavy steel beams welded together in 3-dimensional crosses. Cullen had seen hedgehogs before, but this time something clicked in his mind. He stopped his jeep and walked over to examine one. The obstacle consisted of 3 steel I-beams, each about 6 feet long, welded together at their centers so they formed a 6-pointed star shape. No matter how you dropped a hedgehog, 3 points would always touch the ground and 3 would point upward. The Germans had designed them to stop tanks. The exposed points would catch on a tank's underside and either damage the vehicle or force it to slow down. They were made of hardened steel, thick and heavy. The welds were industrial strength, designed to withstand being run over by 30-ton vehicles. Cullen walked around the hedgehog, his engineer's mind working. These steel beams were exactly what he needed. Strong enough to penetrate compacted earth and old root systems. Heavy enough to provide the mass needed for momentum. Hardened enough that they wouldn't bend or break under stress. And they were everywhere on the beaches, thousands of them, just lying there unused because they'd failed in their intended purpose. The Germans had built anti-tank obstacles that hadn't stopped the invasion. Now those same obstacles could be repurposed to help tanks overcome the hedgerow defense. The idea formed completely in Cullen's mind over the next 10 minutes. Take these steel I-beams. Cut them to length, maybe 4 feet each. Sharpen the tips to create penetrating points. Weld them to the front of a Sherman tank at a downward angle, positioned low on the hull, spaced across the width of the tank. When the tank approached a hedgerow, instead of climbing, it would ram straight into the barrier at speed. The steel prongs would dig into the base of the hedgerow like giant teeth or tusks. The tank's mass and momentum, 30 tons moving at maybe 10 or 15 miles per hour, would drive those prongs deep into the earth and root. Then the tank would just push forward, ripping through the obstruction. The geometry would work. Instead of the tank tilting upward and exposing its belly, it would maintain a level or even slightly nose-down attitude. The thick frontal armor would stay facing toward wherever Germans were positioned. Even if they fired Panzerfausts, the shaped charges would hit sloped 3-inch armor plate and probably bounce off or fail to penetrate. And the best part, it would be fast. No waiting for engineers to plant explosives. No slowly grinding away with bulldozer blades. Just ram through and keep moving. Speed and protection combined. Cullen spent the rest of that day sketching designs in his notebook. He calculated angles. The prongs needed to point downward at about 15 degrees from horizontal. Too shallow and they just scrape the surface. Too steep and they dig in so deep the tank would get stuck. He estimated dimensions. 4 prongs across the front hull, each about 4 feet long and positioned about 2 feet apart. The spacing had to allow chunks of earth and roots to break away and fall out between the prongs rather than building up and creating resistance. He drew side views showing how the tank would approach the hedgerow, how the prongs would bite in, how the vehicle would push through while maintaining frontal armor orientation. The technical challenges were significant but solvable. First, attachment. The prongs had to be welded to the tank's hull in a way that wouldn't compromise the armor's structural integrity. You couldn't just randomly weld heavy steel to a tank and expect it to work. The welds might fail under stress, or worse, the attachment points might create weak spots in the armor that German weapons could exploit. Cullen knew from his mechanical background that the solution was to weld to non-critical areas and use reinforcement plates to distribute the stress across a wider area of the hull. Second, the prongs themselves had to be strong enough to withstand massive forces without breaking. When 30 tons of tank drove steel prongs into compacted 1,000-year-old earth, something had to give. If the prongs snapped or bent, the whole idea failed. But Czech hedgehogs were made of I-beams designed to stop tank. That meant they were already engineered to withstand those kinds of forces. Cullen calculated that if he cut the beams to proper length and reinforced the attachment points, they should hold. Third, weight distribution. Adding several hundred pounds of steel to the front of a tank would affect its balance and handling. The Sherman was already nose-heavy because of its frontal armor and front-mounted transmission. Adding more weight to the front could make the tank handle poorly or put excessive stress on the front suspension. But Cullen figured the weight addition was relatively small compared to the tank's total mass, and Sherman's suspensions had been designed with some overhead capacity. It would change the handling slightly, but probably not enough to create serious problems. By the evening of June 12th, Cullen had refined his design to the point where he thought it could work. But having an idea was one thing. Getting permission to try it was something else entirely. The military ran on procedures and chain of command. You didn't just modify combat vehicles based on a sergeant's hunch. Cullen would need approval from his commanding officer. He'd need access to welding equipment, which was in short supply and tightly controlled. He'd need a tank to modify, and operational tanks were precious resources that commanders were reluctant to risk on experimental modifications. He'd need welders, metal cutters, and time to build the prototype. All of this in a combat zone where resources were scarce and everyone was focused on the immediate crisis. Cullen decided to approach Captain Robert Doughty, who commanded his squadron's maintenance section. Doughty was a by-the-book officer, but he was also frustrated by the hedgerow problem and open to unconventional solutions. The next morning, Cullen found Doughty in the maintenance area, supervising repairs on a damaged reconnaissance vehicle. "Sir, request permission to speak with you about a tactical problem," Cullen said, saluting. Doughty returned the salute and gestured for Cullen to continue. "Make it quick, Sergeant. We've got 6 vehicles down and not enough parts to fix half of them." "It's about the hedgerows, sir. I think I've figured out how to get tanks through them without exposing the belly armor." Doughty's expression shifted from distracted to interested. "That's a bold claim, Sergeant. Every engineer from here to London has been working on that problem. What makes you think you've solved it?" Cullen pulled out his notebook and opened it to his sketches. "Sir, the problem is geometry. When tanks try to climb over hedgerows, they tilt backward and expose their underside. What if instead of climbing, we went straight through at ground level? I've designed an attachment using German steel obstacles from the beaches. Steel prongs welded to the tank's front hull, angled downward. The tank rams the hedgerow at speed. The prongs dig in and rip through the roots and earth. The tank punches through while keeping frontal armor facing forward the whole time." Doughty studied the sketches in silence for a long moment. Cullen could see him working through the concept, testing it mentally against his own knowledge of tactics and mechanics. Finally, Doughty looked up. "The idea is sound in theory, Sergeant. But theory and practice are different things. This hedgerow earth is incredibly dense. Those roots are like steel cables. What makes you think welded-on prongs won't just snap off on first impact?" "Czech hedgehogs are made of hardened steel I-beams designed to stop 30-ton tanks, sir," Cullen replied. "They're already engineered for that kind of stress. If we cut them to proper length, reinforce the welds, and attach them at the right angle, they should hold. The tank's momentum does the work. We're just directing the force." "And you're sure this won't compromise the tank's armor integrity? We can't afford to create weak points that German weapons can exploit." "I've thought about that, sir. We weld to non-critical areas of the lower hull and use reinforcement plates to distribute stress. The attachment points won't be anywhere near existing armor joints or critical structural areas." Doughty was quiet again, thinking. Cullen could see the calculation happening behind the captain's eyes. The idea was unconventional and untested. If it failed, it would waste time, resources, and possibly a tank. But if it worked, it could solve the single biggest tactical problem facing American forces in Normandy. Finally, Doughty made his decision. "All right, Sergeant. Here's what we're going to do. I'm giving you 48 hours to build a prototype. I'll authorize a work detail, welding equipment, and access to beach obstacles for scrap material. But you're not getting an operational tank. There's a damaged Sherman in the salvage yard. Took a hit to the engine compartment, but the hull is intact. You can modify that one. If you can get it mobile and demonstrate that your attachment works, I'll take it up the chain to get you a combat test." "Thank you, sir. I won't waste the opportunity." "You better not, Sergeant. Because if this doesn't work, we'll both be explaining to some very unhappy colonels why we wasted resources on a wild idea while men are dying at the front." Cullen saluted and left immediately to gather his work crew. He found 4 soldiers with welding experience: Private Eddie Kowalski, Corporal James Chin, Private First Class Robert Harrison, and Specialist Tom Mitchell. He explained the concept and showed them his sketches. Their reactions ranged from skeptical to enthusiastic, but all of them were willing to try. They'd all seen too many tank crews die. If there was even a chance this idea would work, it was worth the effort. The first step was acquiring the steel. Cullen led his crew to Omaha Beach in a cargo truck. The beach was still being used as a supply point, with landing craft bringing in equipment and materials continuously. But scattered among the activity were the abandoned German obstacles. Cullen selected 6 Czech hedgehogs in good condition. No severe rust, no damaged welds, steel that looked solid. Using acetylene cutting torches, they cut the hedgehogs apart, separating the I-beams at the central weld point. Each hedgehog yielded 3 beams, so 6 obstacles gave them 18 pieces to work with. More than enough for the prototype, with spares in case anything went wrong. They loaded the steel beams onto the truck and drove back to the maintenance yard. The damaged Sherman they'd been assigned was in rough shape. A German anti-tank round had penetrated the engine compartment from the side, destroying the engine and transmission but leaving the hull structure mostly intact. The tank couldn't move under its own power, but the hull was sound, and that's all Cullen needed for a static demonstration of the attachment system. The next phase was preparation. The steel I-beams from the hedgehogs were about 6 feet long, which was too long for Cullen's purposes. He calculated that 4-foot prongs would provide optimal penetration without creating excessive weight or leverage problems. Using the cutting torches, they cut each beam down to 48 inches. Then they shaped the tip. Cullen wanted penetrating points that would bite into hard earth, so they cut the beam ends at sharp angles, creating chisel-like tip. The cutting and shaping took most of the first day. By evening of June 13th, they had 12 steel prongs cut to length, tips shaped, ready for installation. That night, Cullen barely slept. He kept running calculations in his head. Had he gotten the angle right? Was 4 feet the optimal length, or should they be shorter? Longer? Would the welds hold under combat stress? There were so many variables, so many things that could go wrong. But he thought back to his days as a cab driver in New York, keeping a temperamental vehicle running through brutal conditions with improvised repairs and creative problem-solving. He'd learned that sometimes you had to trust your instincts and practical experience over theoretical perfection. The design was sound. The materials were strong. The concept would work. It had to work. The second day, June 14th, was dedicated to installation. This was the most critical phase. The prongs had to be positioned exactly right. Cullen marked the attachment points on the Sherman's lower front hull with chalk, measuring carefully to ensure even spacing. 4 prongs across the width of the tank, positioned about 2 feet apart. Each prong would be angled downward at 15 degrees from horizontal. The attachment points were on the lower glacis plate, below the main frontal armor but above the belly plate. Welding was tricky. The Sherman's hull armor was hardened steel, which required specific welding techniques to avoid creating brittle spots or weakening the armor. Kowalski and Chen were experienced welders who'd worked in shipyards before the war. They used a technique called butter passing, laying down initial weld passes at lower heat to avoid heat-treating the armor, then building up the weld with multiple passes. First, they welded mounting plates to the hull, thick steel plates about 8 inches square that would serve as the foundation for the prong attachment. The mounting plates distributed stress across a wider area, preventing concentration of force at single point. Then came the prongs themselves. Each steel I-beam was positioned at its designated mounting plate and tack welded in place at the correct angle. Cullen checked and rechecked every angle with a protractor, making sure each prong was at exactly 15 degrees down. Once all 4 prongs were tack welded, they added reinforcement. Triangular gusset plates were cut from scrap steel and welded between each prong and the hull, creating a rigid triangular structure that would resist bending forces. The gussets were critical. Without them, the prongs might lever against their mounting points under stress and tear free. The welding took hours. Each weld had to be perfect, built up in multiple passes, inspected for cracks or voids, then reinforced. By mid-afternoon of June 14th, all 4 prongs were installed. The Sherman now looked like some medieval battering ram, with 4 steel tusks jutting forward from its front. It looked crude and almost comical, but Cullen thought it was beautiful. This ugly modification might just save hundreds of lives. The final step was testing the welds. They used sledgehammers to strike the prongs from various angles, checking whether the welds would hold under impact. Everything stayed solid. The mounting plates didn't shift, the welds didn't crack. The attachments were as strong as the base metal. Structurally, the modification was sound. But the real test was still ahead. Would it actually work against a hedgerow? Would the prongs penetrate the dense earth and roots, or would they just bounce off or snap? Would the tank be able to push through, or would it stall out? There was only one way to find out. Captain Doughty arrived late in the afternoon to inspect the completed modification. He walked around the tank slowly, examining the welds, testing the prongs with his hand, checking the angles. Finally, he stepped back and nodded. "Well, Sergeant, you built exactly what you said you'd build. Now we need to see if it works. Tomorrow morning, we're taking this to a test range. I've selected a hedgerow for you to attack, a real thick one that's been stopping everything. If your modification can breach that hedgerow, you'll get your combat test." Cullen felt his stomach tighten. Tomorrow would determine whether his idea was genius or foolishness, whether he'd just wasted 48 hours and valuable resources, or whether he'd solved one of the biggest problems facing the American army in Normandy. That night, he couldn't sleep at all. He lay in his tent, staring at the canvas ceiling, running through every possible failure mode. What if the prongs snapped on impact? What if they dug in too deep and the tank got stuck? What if the modification actually made things worse somehow? But then he thought about the burning tanks, the dead crews, the endless stalemate in the bocage. Doing nothing wasn't an option. Even if his idea failed, at least he'd tried. At least he'd done something besides watch good men die. At dawn on June 15th, Sergeant Curtis Cullen climbed onto the modified Sherman, ready to test whether a cab driver's sketch in a notebook could change the course of the war. The morning sun had barely cleared the horizon when Cullen's modified Sherman rolled toward a particularly thick hedgerow selected for the test. It was a beast of a barrier, 12 feet high, ancient, impenetrable-looking. Several officers had gathered to watch, including representatives from division headquarters. This wasn't just a field test anymore. Word had spread about the crazy sergeant with the scrap metal solution, and now people wanted to see if it actually worked. The Sherman's crew had volunteered for the test. They were either brave or crazy, possibly both. As they buttoned up the hatches and the engine rumbled to life, the gathered soldiers fell silent. Cullen stood with the observers, his heart pounding. Everything he'd calculated, everything he'd built, came down to the next 60 seconds. The signal was given. The Sherman's engine roared louder. Black smoke belched from its exhaust. Then, with gathering speed, it charged directly at the hedgerow. 30 tons of steel accelerating toward what looked like an immovable object. The impact was thunderous. The entire tank shuddered. Earth exploded outward. Roots snapped with sounds like rifle shot. For a moment, the tank seemed to stall, embedded in the hedge mass. Soldiers held their breath. Then, slowly at first, the Sherman began to move forward. The steel prongs were working. They were digging deep into the ancient earthwork, ripping through roots and stone. The tank tilted forward slightly, not exposing its belly, but maintaining a nose-down attitude that kept frontal armor facing forward. More roots snapped. Dirt cascaded off the tank's hull. The engine screamed with effort. And then, suddenly, the Sherman burst through the other side of the hedgerow. The tank had created a perfect breach, wide enough for other vehicles to follow, executed without ever exposing its vulnerable underside. The soldiers erupted in cheers. Cullen felt his knees go weak with relief. It had worked. His crazy idea had actually worked. The crew popped their hatches and emerged, grinning. "That was the smoothest hedgerow crossing we've ever done," the driver shouted. "We barely felt it inside, and we never once exposed our belly." An officer from division headquarters approached Cullen, his expression serious. "Sergeant, how many of these modifications can you produce? And how quickly?" "Sir, if I get enough welders and access to more scrap metal, we could modify 10 tanks a day. Maybe more if we really push it." "Not good enough," the officer said, and Cullen's heart sank. Then the man smiled. "I'm getting you 50 welders and all the steel you need. I want 100 tanks modified by the end of the week, and I'm sending a report to General Bradley immediately. But Cullen wasn't celebrating yet. Sir, with respect, one successful test doesn't mean it'll work in combat. We need to try this against an actual German position with real enemy fire. The officer nodded grimly. I thought you might say that. There's a German strong point 2 miles from here. They've been holding up our advance for days. If your modification works there under fire, you'll have proven your concept beyond any doubt. The combat test came the next morning. Cullen's modified Sherman, now nicknamed Rhino by the crew, would lead a small column toward a German position that had been stopping American advances for 3 days. Intelligence said there were at least 2 machine gun nests and possibly an anti-tank gun positioned behind the hedgerows. Standard tactics would mean exposing tanks to devastating fire. The Rhino represented a different approach. Cullen rode along as a technical observer, positioned where he could see how his modification performed under actual combat conditions. His stomach churned with nervous energy. If this failed, if the prongs snapped or the tank got stuck or any of 1,000 things went wrong, good men would die. And it would be his fault. The Rhino approached the first hedgerow with German positions on the other side. No hesitation, no slow climb. The tank accelerated and hit the hedgerow at speed. The impact was massive, but the prongs bit deep. Earth and roots exploded. The tank punched through in seconds, emerging on the far side before the shocked German machine gun crew could react. The Sherman's main gun fired first. One high-explosive round that eliminated the threat before the Germans even reached their weapons. "It works," someone shouted over the radio. "It actually works in combat." The Rhino continued forward, breaching hedgerow after hedgerow. Each time, the tank emerged before Germans could bring weapons to bear. Infantry following behind were ecstatic. For the first time since D-Day, they could advance without being pinned down by hedgerow defenses. Then came the real test. Intelligence had warned about a German anti-tank gun positioned behind a particularly massive hedgerow. If the Rhino got stuck breaching that barrier, it would be a sitting duck. The tank commander made a split-second decision. They'd breach at speed, gambling that surprise and momentum would carry them through before the Germans could respond. The Sherman surged forward. The impact was the hardest yet. This hedgerow was thicker than any they'd hit. For a terrifying moment, the tank seemed to slow. Then the engine howled, the tracks churned, and inch by inch, the Rhino forced its way through. They burst out the other side at an angle, gun already trained on where the German position should be. There it was. A PK-40 anti-tank gun, its crew frantically trying to traverse their weapon to track the unexpected target. The Sherman fired first. The armor-piercing round struck the gun shield, and the German weapon was silenced. The infantry caught up, securing the position. An officer approached the Rhino, grinning broadly. "Sergeant Cullen, I don't know what kind of magic you worked, but you just did in 2 hours what we've been trying to do for 3 days. Cullen climbed out of the tank, his legs shaky. He'd done it. The design worked not just in a controlled test, but in actual combat against real enemy positions under fire. Word spread fast. Within hours, reports were climbing the chain of command. Within days, General Omar Bradley himself had heard about the sergeant with the welded scrap metal who'd solved the hedgerow problem. Bradley ordered immediate mass production. Every tank depot in Normandy received orders to begin installing what were now officially called Cullen hedgerow cutters, or Rhino devices. The army brought in welding teams from engineering battalions across Normandy. They scavenged more Czech hedgehogs from the beaches. The very obstacles Germany had placed to stop the invasion were now being repurposed to break through their defensive positions. They set up assembly lines in fields, working around the clock. Cullen found himself pulled from his unit and assigned to train welding crews. He went from depot to depot, showing them the exact angles for the prongs, the proper welding techniques, the reinforcement methods that would keep the cutters from snapping under stress. The key, he'd explained to each new group, is that the prongs have to dig in low. Too high, and the tank tilts up and exposes its belly. Too low, and they just plow dirt without cutting root. You want them positioned exactly here. He'd mark the spot with chalk, at about a 15-degree downward angle. Within a week, hundreds of tanks had been modified. Within 2 weeks, over 1,000. The transformation was remarkable. Suddenly, American armor could advance through the bocage country without the suicidal exposure that had been costing so many lives. Tank casualties from belly hits dropped dramatically. The pace of advance increased. German defensive positions that had seemed impregnable were suddenly vulnerable. The psychological impact on German defenders was significant. They'd relied on the hedgerows as natural fortifications. When American tanks started plowing through barriers that were supposed to be impassable, it shattered German confidence in their defensive positions. After-action reports captured later in the war showed German confusion. Enemy armor is now passing through hedgerows without exposing vulnerable areas. Unknown how this is being accomplished. General Bradley visited one of the tank modification sites personally. He found Cullen training a welding crew. "Sergeant Cullen, I presume?" Cullen snapped to attention, recognizing the stars on Bradley's collar. "Yes, sir." "At ease, Sergeant. I came to see the man who unstuck my army." Bradley smiled. "Your invention is brilliant in its simplicity. We've been throwing sophisticated solutions at the hedgerow problem for weeks, and then you come along with scrap metal and a welding torch and solve it in 2 days." "Sir, I just did what needed doing." "That's what good soldiers do," Bradley said. "I'm recommending you for the Legion of Merit, and I'm authorizing a field promotion to technical sergeant." But the recognition made Cullen uncomfortable. He was being lauded as a genius, receiving medals and promotions, but men were still dying in Normandy. His invention was helping, but the war was far from over. "You okay, Sarge?" one of his crew asked. "You don't seem excited about all this." "I am," Cullen replied quietly. "I just keep thinking about all the crews we lost before this invention. What if I'd thought of it sooner?" "You can't think like that. You can't save the guys who died before. But you're saving the guys who are still alive. Every day, more tanks with your cutters are rolling through hedgerows. Every day, fewer crews are burning. That's what matters." By late July 1944, the Cullen hedgerow cutter had become standard equipment on American tanks in Normandy. This timing was critical because General Bradley was planning Operation Cobra, the massive offensive that would finally break out of the Normandy bocage and allow Allied armies to race across France. The operation kicked off on July 25, 1944, with a massive aerial bombardment followed by ground assault. American armor, now equipped with hedgerow cutters, punched through German defensive lines that had held for weeks. What would have been a grinding, costly advance became a breakthrough. Tanks that previously would have been stopped by every hedgerow now breached through multiple barriers without slowing. The German defensive system in Normandy had relied heavily on the natural obstacles of the bocage terrain. When American tanks suddenly gained the ability to negate those obstacles, the entire defensive concept collapsed. German units found themselves being outflanked and surrounded as American armor moved through terrain the Germans had considered impassable. Within days, Operation Cobra had torn a massive hole in German lines. Within weeks, Allied forces were racing across France. Paris was liberated on August 25, 1944. By September, Allied armies were approaching the German border. The Normandy breakout, which military historians credit in significant part to the hedgerow cutter, had succeeded beyond even optimistic projections. Curtis Cullen never claimed his invention won the war. He was too modest for that, and too aware of all the other factors involved. But military analysts who studied the Normandy campaign concluded that the hedgerow cutter had shortened the bocage fighting by weeks, possibly months. Every day saved meant lives saved, resources conserved, momentum maintained. General Dwight D. Eisenhower, Supreme Allied Commander, later called the Culin hedgerow cutter, one of the most significant tactical innovations of the war. Official Army reports credited it with materially contributing to the successful conclusion of the Normandy campaign. Curtis Culin returned home to New York after the war, carrying his Legion of Merit and Bronze Star, but ready to leave combat behind. He went back to civilian life, working various jobs, raising a family. He never talked much about the hedgerow cutter. When people would ask about his war service, he'd deflect. "I was a mechanic. Fixed some tanks. Nothing exciting." He didn't mention the medals, the innovation, the fact that his invention had changed the course of history. His family once asked him why he never discussed his wartime achievement. "I'm proud of what I did," Culin replied quietly. "But I'm not proud of what it was for. I made a tool that helped kill people. It saved American lives, which matters. But it was still about killing. I'd rather focus on the present." Over the decades, military historians gradually recognized the significance of the Culin hedgerow cutter. It appeared in books about the Normandy campaign, in documentaries about World War II innovations, in military training manuals as an example of field expedient engineering. But Culin himself remained largely unknown outside military history circles. In the 1980s, historians tracking down veterans of the Normandy campaign finally located Culin and interviewed him. He was elderly by then, but still sharp, still modest. "Do you understand how significant your invention was?" a historian asked. Military analysts estimate it shortened the Normandy campaign by weeks. It saved thousands of lives. Culin was silent for a long moment. Then he said something the historian would quote extensively. "I wasn't special. I was just a guy who knew how machines worked and saw a problem that needed solving. The special part was that the Army gave me a chance to try. How many other good ideas got dismissed because they came from the wrong person? I got lucky. My idea got tested. But I guarantee there were 100 other guys with equally good ideas that nobody listened to." "But your idea worked," the historian pressed. "That makes you special." "My idea worked because people gave it a chance," Culin corrected. "That's the real lesson. Not that I was some genius, but that good ideas can come from anywhere if you're willing to listen." Curtis G. Culin Jr. died on May 13, 1963, in Cranford, New Jersey. He was 52 years old. His obituary in the local newspaper mentioned that he'd been a veteran and worked various jobs. It didn't mention the hedgerow cutter. Most of his neighbors never knew that the quiet man who'd lived among them had changed the course of World War II. But in military museums across America and Europe, examples of the Culin hedgerow cutter are preserved. Chunks of steel welded to the fronts of Sherman tanks. Simple, crude-looking, but revolutionary in their effectiveness. Plaques explain what they are and what they did. And they mention the name Curtis G. Culin Jr., the sergeant who refused to accept that problems were unsolvable. The Culin hedgerow cutter represents something larger than just one tactical innovation. It's a story about how warfare rewards adaptability, how simple solutions can solve complex problems, and how innovation can come from unexpected places. Military historians studying the Normandy campaign point to several factors that contributed to Allied success: air superiority, naval gunfire support, overwhelming material advantage. But they also point to the hedgerow cutter as an example of tactical innovation at the squad level making strategic impact. One sergeant with a welding torch and scrap metal had accomplished what teams of engineers with advanced degrees couldn't. The hedgerow cutter also changed how the U.S. military thought about field modifications and soldier innovation. After World War II, the Army established more formal systems for collecting and evaluating ideas from soldiers at all ranks. The assumption that expertise only came from the top down had been proven wrong. Good ideas could come from anywhere. Modern military doctrine now emphasizes adaptability and field innovation as core competencies. Special operations forces in particular train their personnel to improvise and modify equipment based on mission requirement. This traces back, in part, to lessons learned from innovations like Cullen's hedgerow cutter. The story also reminds us that warfare creates several problems that peacetime planning can't anticipate. American planners had studied maps of Normandy, but they'd underestimated how the bocage terrain would impact armored operations. They'd trained for breakthrough and exploitation, not for grinding hedgerow-to-hedgerow fighting. When unexpected problems arose, the solution came not from headquarters, but from a sergeant who saw things differently. Today, preserved examples of hedgerow cutters can be found at the National World War II Museum in New Orleans, the Bovington Tank Museum in England, and various other military history collections. They look primitive, just steel prongs welded to tank hulls. But they represent one of those rare moments when a single individual's ingenuity changed the course of history. Curtis Cullen never sought fame. He never wrote a book or gave lectures, never. He returned to civilian life and lived quietly. But his legacy endures in military doctrine, in museum exhibits, and in the survival of thousands of tankers who came home because their Shermans could punch through hedgerows without exposing their bellies to enemy fire. The sergeant with the scrap metal and the crazy idea had done something remarkable. He'd seen a problem everyone else accepted as unsolvable, and he'd solved it. Not with advanced technology or complex engineering, but with simple physics, practical mechanics, and the willingness to try something nobody else had thought of. That's the real story of the Cullen hedgerow cutter. Not just what it did, but what it represents. The power of individual initiative, the value of practical problem solving, and the reality that sometimes the best solutions come from the most unexpected places.